In this video, we'll look at how you can calculate the formulae for acids. You'll probably learn the formulas for acids as you use them, but this is a way you can use to work out the formula. So acids are ionic substances. They consist of hydrogen ions in solution, and that's what makes the solution acidic, as well as other ions depending on what the acid is that you're using. Page 8 in the data book is going to be a valuable resource. So this is a list of all the various group ions. So for example, the carbonate group ion here is a carbon with 3 oxygens attached to it, and that whole thing has a charge of 2 minus. The charge on the ion will tell you the valency. So all of these with the 2 minus charge here will have a valency of 2. The phosphate group ion, which is PO4, that has a valency of 3 because it's got a charge of 3 minus. All of these ones here all have a charge of 1 minus. They'll all have a valency of 1. If we look at the names and what ions are in solution in various acids, you'll notice first of all that all acids contain hydrogen ions in solution. That's what makes the solutions acidic. And as well as the hydrogen ions, there are various other ions depending on what the acid is. The name of the acid will give you a clue as to what the other ions are as well as hydrogen ions. So in hydrochloric acid, it's got chloride ions. In nitric acid, it's got the nitrate group ions. Sulfuric acid contains the sulfate group ion. Phosphoric acid contains the phosphate group ion. And ethanoic acid contains the ethanoate ion. You'll see, for example, the ethanoate ion, you'll see is there on page 8 in your data book. So we can use page 8 in the data book there to work out what ions are present using the name of the acid, and then we can work out the formula. So to work out the formula for acids, you can use the valency rules. So for hydrochloric acid, remember the first thing you do is to write down the symbols of the elements or group ions that you've got present. So in hydrochloric acid, we've got hydrogen and chlorine. We then write down the valency of these two substances. So hydrogen has a valency of 1 and chlorine has a valency of 1. We then see if we can simplify these numbers. We can't simplify 1 and 1, so we simply write them as 1 and 1 again. We then swap the numbers over, and then this will tell you the valency. So here, this is telling us for every 1 hydrogen, we've got 1 chlorine. So the formula will be HCl. In nitric acid, again, we write down the symbols. For hydrogen, it's H, and for the nitrate group ion, it's NO3. Don't forget this little 3 here when you're writing nitrate, because it's a nitrogen and 3 oxygens going around as a little group. The valency of hydrogen is 1, and the nitrate group ion also has a valency of 1. So remember the NO3 minus, the 1 minus charge tells us it's got a valency of 1. We can't simplify them, so we simply write 1 and 1 again, swap the numbers, and this again tells us that for every 1 hydrogen, I've got 1 nitrate group. So the formula is HNO3. In sulfuric acid, we've got hydrogen ions again, and in this case, we've got sulfate group ions. And the sulfate group ion is SO4. It's a sulfur and 4 oxygens going around together as a group, and that has a charge of 2 minus. So we know hydrogen has a valency of 1, and the sulfate group ion has a valency of 2. Again, we can't simplify 1 and 2, so we just simply write them again, swap the numbers. This tells us that we need 2 hydrogen for every 1 sulfate. So the formula is H2SO4. Phosphoric acid follows the same rules. Again, we write hydrogen, and in this case, the phosphate group ion. And the phosphate group ion has a charge of 3 minus, so it's got a valency of 3. So hydrogen has a valency of 1, and the phosphate group ion has a valency of 3. We can't simplify 1 and 3, so we write the numbers again, swap the numbers over, and this tells us that for every 3 hydrogens, we've got 1 phosphate group ion. So that's a formula of H3PO4. And the odd one out really is ethanoic acid. In all of the other acids we've seen so far, the hydrogen has always come first in the formula. The ethanoic acid is a little bit different. That's actually got the ethanoate group ion in it. And we're going to write that down first, and I'll show you why in a second. But the ethanoate ion is CH3COO, and that has a charge of 1 minus. So it's got a valency of 1. And we also know hydrogen's got a valency of 1 again. Can't simplify 1 and 1, so we write the numbers down, swap the numbers over, and this tells me that for every one ethanoate ion, I've got one hydrogen ion. So that's a formula of CH3COOH. So you can now see that the H is actually coming at the end of this formula. It's not at the beginning like for all of the other acids we've seen so far. Now it's written at the end. And the reason for that is if you look at the structure for the ethanoate ion, this is the CH3, it's a carbon with 3 hydrogens attached to it. And this is the COO minus. Okay, this oxygen here is where the hydrogen is going to join on to. So this is the H plus ion, and it's going to join on to this O minus bit there. So this is what it forms. And this is actually the structure for the ethanoic acid. So the hydrogen joins onto this oxygen here. If we wrote it down as HCH3COO, then this H would be trying to join onto a carbon that's already got the 4 bonds it needs. So the hydrogen has to join onto this oxygen here. And that's why in ethanoic acid, we always write it down as CH3COO and then the H. So using valency rules, you should be able to work out the formula for any acids.